In the deepest, most hostile place on Earth, a new flag has been planted. While the world was gazing upward at the stars, China was looking downward into a realm we understand less than the surface of Mars. What they are finding in the crushing blackness is changing everything. Subscribe for more deep ocean mysteries grounded in real science and history. The discoveries being made in the world's oceans are not simply scientific curiosities. They represent a fundamental shift in how we understand life on our own planet. This is a story of impossible biology, sweeping global ambition, and a new kind of geopolitical race unfolding miles beneath the waves. For generations, scientists believed the Hadal Zone, ocean depths beyond 6,000 meters, was largely barren and lifeless. Total darkness, near freezing temperatures, and pressures capable of crushing military-grade steel made it seem like an uninhabitable void. Early researchers described it as desolate, alien, and almost entirely devoid of complex life. Pioneering dives into these extreme depths were incredibly rare events, perhaps occurring once per generation. The technology simply did not exist to make such journeys routine or repeatable. Filmmaker James Cameron's famous solo descent into the Mariana Trench stood as a singular, historic achievement that few believed could ever be regularly replicated. All of that has now changed. A new race to the very bottom of the ocean has begun, and China is leading it with remarkable speed, extraordinary investment, and a clear long-term strategy. The country is deploying entire fleets of deep-sea explorers and building the infrastructure needed to operate where almost no one else can. At the heart of this new era is a remarkable piece of engineering, a manned submersible called Fendouzhe, meaning striver in English. This vessel is no ordinary submarine. It is specifically built to endure pressures exceeding 1,000 times those experienced at the ocean's surface, enabling repeated dives to the extreme bottom. In November 2020, the Fendouzhe carried 3 crew members to a staggering depth of 10,909 meters inside the Mariana Trench. A Chinese flag was planted on the seafloor, and for the very first time in history, live video was broadcast directly from the Challenger Deep to audiences watching on the surface above. That landmark dive marked a profound turning point in ocean exploration. What had once been a singular, once-in-a-generation event was transformed into a consistent and scalable operation. By early 2024, China's fleet of submersibles had completed hundreds of dives, turning the extreme deep sea into a regular destination rather than an extraordinary exception. The real question, then, is not simply how China is reaching these impossible depths with such growing frequency. The more pressing question is what they are so determined to find down there. The scale of investment, the pace of exploration, and the strategic framing all suggest that the answers go far beyond pure scientific curiosity. The first major answers began arriving recently, delivered through a series of groundbreaking findings that stunned researchers worldwide. A Chinese-led team from the Institute of Deep Sea Science and Engineering published their results in the prestigious journal Nature. Their dives into the Kuril-Kamchatka trench did not reveal the expected emptiness. They found something extraordinary instead. At depths reaching 9,533 meters, deeper than Mount Everest is tall, the research team discovered something no one had anticipated finding at such extreme depths. Rather than the barren, lifeless seafloor that scientists had long assumed existed there, they encountered a vibrant, thriving oasis of biological activity unlike anything previously documented at such pressure. The sheer density and variety of life found at these depths immediately challenged decades of established scientific thinking. This was not merely a handful of microscopic organisms clinging to survival. Researchers observed dense, flourishing communities of complex creatures covering the seafloor in ways that defied every existing model of what deep-sea ecosystems were capable of sustaining. Among the most striking discoveries were fields of tube worms stretching nearly a foot in length, alongside extensive beds of clams and unusual crustaceans carpeting the seafloor. These were not isolated specimens. They existed in concentrated, interconnected communities, suggesting a well-established and self-sustaining ecosystem had been quietly thriving in total darkness for an unknown period of time. The key to understanding how life survives in such an extreme environment lies in a process called chemosynthesis. Unlike virtually all life on Earth's surface, which ultimately depends on sunlight for energy, these deep-sea creatures draw their nourishment from chemical reactions. They harness energy released by hydrogen sulfide and methane seeping upward through cracks in the seafloor. This chemical energy, rather than solar energy, powers entire food webs in absolute darkness. Microbes convert the seeping chemicals into biological energy, forming the foundational layer of a complex ecosystem. Larger organisms then feed on these microbes, creating layered communities that function completely independently from the sun-driven world existing miles above them on the ocean's surface. Researchers quickly realized they were witnessing something far more significant than a localized biological curiosity. What the Fendouzhe had revealed was a vast, active, and entirely previously unknown biosphere operating at extraordinary depth. The scale and complexity of what they found forced an immediate and serious reconsideration of long-held assumptions about the limits of life on Earth. For decades, the dominant scientific view held that deep-sea life survived primarily on marine snow, tiny fragments of organic material slowly drifting downward from the sunlit layers above. These new discoveries directly challenged that model. The ecosystems found in the Kuril-Kamchatka trench were not dependent on surface life at all. They were generating their own energy entirely from below. The lead researcher on the project described what was found as the deepest and most extensive chemosynthetic community ever identified on our planet. That description alone carries enormous weight. It means these ecosystems are not simply unusual edge cases. They represent a significant and previously uncounted component of the ocean's overall biological activity and carbon processing capacity. Beyond the immediate biological implications, these findings carry profound consequences for our understanding of the deep-sea carbon cycle. If methane-fueled ecosystems are processing and transforming carbon at these depths on a large scale, then existing models of how carbon moves through the global ocean may need significant revision. The deep ocean, it turns out, is far more active than assumed. Perhaps most provocatively, these discoveries extend their implications beyond Earth entirely. If life can thrive in total darkness using only chemical energy and extreme pressure, then similar conditions on other worlds become far more promising. The icy moons of Jupiter and Saturn, known to harbor subsurface oceans rich in chemicals, suddenly seem far more likely to host life of their own. While China was making record-breaking biological discoveries in the crushing depths of the Pacific Ocean, it was simultaneously executing a quieter but equally ambitious strategy at the opposite end of the planet. Far to the north, in the rapidly changing Arctic region, China was carefully and methodically positioning itself as an indispensable player in a part of the world it has no geographic claim to. For years, China has been building the argument that it deserves a meaningful seat at the Arctic table. Beijing officially describes itself as a near-Arctic state, a designation with no formal geographic basis but carrying significant political intention. The argument is straightforward. The future of the Arctic affects all of humanity, and therefore all major nations should have a voice in shaping it. Crucially, China is not attempting to assert this presence through military force or direct territorial claims. Instead, it is using a far more sophisticated and difficult-to-counter approach: science. Through widespread scientific diplomacy, research partnerships, and long-term investment in polar expertise, China is embedding itself into the Arctic's future in ways that are legitimate, welcomed, and increasingly hard to disentangle. A significant milestone came in 2013 when China was granted observer status within the Arctic Council, the primary international body governing the region. Rather than treating this as a symbolic gesture, Beijing used it as a launching pad. Since that moment, China has dramatically and consistently expanded the scale and ambition of its polar research presence year after year. Central to China's Arctic strategy are its two purpose-built polar icebreakers, the Zhulong and the newer, more advanced Zhulong 2. These vessels are now a regular and recognizable presence in Arctic waters, conducting scientific missions across multiple seasons. Their continued operation signals not occasional interest but a sustained, long-term commitment to understanding and influencing the region's evolving future. China has also been deliberate and strategic in building scientific partnerships with established Arctic nations. With Russia, it conducts extensive joint climate research studies. With Finland, it combines cutting-edge Chinese remote sensing technology with deep Finnish expertise in ice behavior and dynamics. Each partnership quietly deepens China's technical knowledge while also strengthening its political relationships across the region. One of the most concrete symbols of China's Arctic ambitions is the China-Iceland Arctic Science Observatory, a permanent research facility that gives Beijing a fixed, year-round foothold for atmospheric and environmental monitoring in the high Arctic. Permanent infrastructure represents permanent presence. And permanent presence translates directly into influence over how the region's future is discussed, governed, and ultimately decided. On the surface, all of this research activity is presented as a genuine and altruistic global contribution to understanding climate change. Chinese scientists are drilling through ancient ice cores, studying subglacial lakes hidden beneath kilometers of frozen water, and collecting atmospheric data of genuine scientific value. Much of this work is real, serious, and contributes meaningfully to collective human knowledge. However, many international observers and analysts see a clear dual purpose running beneath the surface of China's polar scientific engagement. The research infrastructure, the partnerships, and the accumulated expertise are not only producing scientific papers. They are simultaneously laying the groundwork for something with far more immediate and tangible economic value: the Polar Silk Road. The Polar Silk Road is China's proposed commercial shipping route running through Arctic waters, connecting Asia directly to Europe via the north. As climate change melts Arctic sea ice at an accelerating rate, this route is becoming increasingly navigable. A functional northern shipping lane would dramatically reduce travel distances, cutting journey times and fuel costs in ways that would reshape global trade flows significantly. By investing heavily in Arctic research and becoming an indispensable scientific partner to established polar nations, China is doing something far more strategic than simply collecting data. It is embedding itself into the region's governance structures and future decision-making processes, ensuring that when critical choices about Arctic access and resources are made, Beijing will have a legitimate and established voice. While other nations remain focused on the immediate and pressing challenges of climate change and environmental protection, China is simultaneously playing a much longer and more calculated game. Science is being used not merely as an end in itself, but as a tool to secure strategic positioning and economic advantage in a region that is opening up faster than most people realize. So what exactly connects strange new tube forms discovered at the bottom of the Pacific Ocean to a Chinese icebreaker quietly cutting through Arctic waters thousands of miles away? The answer, when examined carefully, boils down to two interconnected and enormously consequential things: access to untapped natural resources and the pursuit of long-term geopolitical dominance over Earth's last frontiers. The discovery of vast chemosynthetic ecosystems in the deep ocean is not merely a triumph of biological science. These unique communities, thriving under conditions of extreme pressure, total darkness, and intense chemical activity, represent a potential goldmine for the rapidly growing field of biotechnology. The organisms surviving here may hold answers to questions we have not yet thought to ask. The microbes and creatures inhabiting these extreme deep-sea environments could potentially yield entirely new classes of medicines. Novel industrial enzymes capable of functioning under conditions that would destroy conventional ones, and advanced biomaterials with properties we cannot yet fully imagine. Every organism discovered in these chemosynthetic oases is a biological blueprint shaped by millions of years of adaptation to impossible conditions. Beyond biology, the physical locations where these ecosystems are found carry their own immense strategic value. Deep-sea trenches, hydrothermal vents, and chemosynthetic seep sites are frequently associated with significant deposits of valuable minerals and rare earth elements. These materials are critically important components in the manufacture of smartphones, electric vehicle batteries, renewable energy infrastructure, and advanced military technology. As nations around the world compete intensely for technological supremacy and supply chain security, the ocean floor is rapidly emerging as the next major battleground for these essential resources. Whoever maps these deposits most thoroughly develops the technology to extract them most efficiently, and establishes the strongest legal and diplomatic frameworks around deep-sea mining will hold an enormous and lasting strategic advantage. China's scientific engagement in the Arctic follows precisely the same underlying logic. The region sits atop vast and largely untapped reserves of oil, natural gas, and mineral wealth. Reliable estimates suggest the Arctic holds a significant fraction of the world's remaining undiscovered hydrocarbon reserves. Control over future shipping lanes connecting those resources to global markets represents an immense and compounding strategic prize. In both the crushing abyss of the deep ocean and the rapidly thawing frozen north, China is systematically transforming scientific exploration into durable strategic infrastructure. Every dive, every research station, every partnership, and every published dataset is simultaneously a contribution to human knowledge and a calculated move in a much larger, Global competition being played out across Earth's most remote environments. From the deepest trenches of the Pacific to the melting ice sheets of the Arctic, China's ocean expeditions are revealing a world far more complex, active, and consequential than humanity ever imagined. The discoveries are genuinely astounding, but the implications reach further still. As this accelerating new age of ocean exploration unfolds, the most important question may simply be, what comes next?